Good day, grade 11s. Today, I would like to continue working through Newton's second law problems, and I'm going to focus on pulley problems. So there are pulleys in the system. Now, a pulley does not have any other function but to change the direction of the string or the chain or the cable to which objects are connected, and so it changes the direction of the tension in the rope or the chain or the string. Our first example says a horse exerts a horizontal force of 5,000 Newton on a rope to lift a load of 400 kilograms vertically. The horse is connected to the load over a frictionless pulley. So this is our frictionless pulley, and the force that is applied at that point by the horse is 5,000 newtons. The mass of the crate is, or the load is 400 kilograms. From that, we can calculate the gravitational force. Now, whenever we need to solve a problem like this, we need to draw a free body diagram to indicate all the forces acting on the load. So that is our starting point. Now, this question asked for us to draw the free body diagram. They don't always ask you to draw the free body diagram. So it is step number one that we need to follow. So the load has a gravitational force Fg, and there's a tension up, and that tension is the same as the applied force of 5,000 newtons. They want us to calculate the acceleration of the load. That is the only unknown. One unknown requires one equation. And we start off by using Newton's second law. F net equals ma. Then we use ma and we build our equation for addition of vectors. We need to decide, is the tension in the positive direction or is the gravitational force in the positive direction? I'm going to choose up for tension as my positive direction. That would mean that gravitational force Fg would be in the negative direction. So to build the equation, I say tension, or if applied, in this case it doesn't matter, minus Fg. Now the mass of the object is 400 kilograms. The acceleration is the unknown. The applied force is 5,000 newtons. And the mass of the load is 400, and the gravitational acceleration is 9.8. If we do our simple mathematics here, it's 5,000 minus 400 times 9.8. Get the answer there, 1,080, and divide that by 400. So The answer I get is 2,7 meters per second squared upwards. Right, that brings this problem 1, to an end. Example 2, we have two masses of one of 2 kilogram and the other of 4 kilogram that are connected with a cable of negligible mass over a frictionless pulley. This is commonly referred to as an Atwood machine, and it is used in every elevator in the world. Calculate the acceleration of each block. Now, because they're connected, they will have the same acceleration. Block M1 would accelerate upwards, block M2 would accelerate downwards, but the magnitude of the acceleration would be the same. Then they want us to calculate the tension in the rope to which the blocks are attached. Now, to do this, I need to acknowledge that acceleration is unknown and that the tension that acts up here in the rope and down and up there in the rope, so the tension in this part of the rope and the tension in this part of the rope is exactly the same tension. It's just acting in opposite directions. So I'm going to just use T for tension. Now, they have not asked us to draw a free body diagram for each block, but in order to solve the problem, I need to be able to visualize the situation, and I need to identify all the forces acting on each of the blocks. So that is up, tension, and down would be Fg. For the 4 kilogram object, the Fg is down and the tension is up. Now, another easy way to remember is that a pulley changes the direction of a force, like in this case the tension. And I need to decide which direction would be the positive direction. If I look at M1, it looks like this thing is going to move up. So I'm choosing up as my positive direction for this object. Then down would be the negative direction. The pulley changes the direction of the tension. So if the tension in this first diagram is positive, I'm going to choose that as my negative direction because it's the opposite direction. And my Fg is then the positive direction. Next, to use Newton's laws to build the equation. Newton's second law, F net equals ma. Then ma would be tension minus Fg in this case. I can write Fg in terms of mass and gravitational acceleration. I'll say m1 times acceleration is tension times m1 g. So 2a equals tension is unknown minus 2 times 9.8. So my first equation is 2a equals tension minus 19.8. 0.6. This is my first equation. My second equation would be M2A equals M2G minus T. To substitute the values that we have, 4A equals 4 times 9.8 minus T. To simplify further, 4A equals 0.6 times 2, which is 39.2 minus T. And this forms the second equation. Two unknowns, these two, acceleration is unknown and tension is unknown. So we need two equations. I notice that here tension is in the positive direction in equation 1, and in equation 2, tension is in the negative direction. What's happening here? Come on. Sounds like there's a retarded motion here. Tension is negative. Righto, so if we add the two equations, then we should get the tension sorted out. So equation 1 plus equation 2 will give me 6A. The tension is cancelled. Minus 19.6 plus 39.2. So A is 19.6 divided by 6, which gives us 3.27. 3.27 meters per second squared, and it would be up for M1 and down for M2. So this thing is going to accelerate clockwise. That's the direction of the acceleration. Number B, we need to calculate the tension in the rope which the blocks are attached to. So what I'll do is I'll use equation 2. So this is number B, and I'm going to say 4 times 3.27 equals 39.2 minus the tension. So tension would be the 39.7 minus the 4 times 3.27, 3.27. And I get tension to be 26.62 Newton. Right, so we moved from one unknown in question 1 to two unknowns in question 2. Ready for the next challenge? Right, just clear all those. Here we have the two objects hanging from a string. The one object is below the other one. And there's a force of 120 Newton applied to the left after the string ran over the pulley. In the diagram, a constant force of 120 Newtons It's used to lift two mass pieces, A of 4 kilogram and B of 6 kilogram, which are tied to each other. Ignore the masses of the string as well as any friction. So the pulleys are usually always frictionless. Question A, draw free body diagrams of the forces acting on each mass piece. So for A, there is a tension upwards, and that tension, the size of it is 120 newtons. There's a string between A and B, so there must be a tension 2. I'm going to call that initial tension or the applied force as T1. This I will call T2, and there is a weight, Fg of A. For the second object, B, there is a tension upwards, and that would be T2, and a gravitational force downwards, that would be Fg of B. There we have our free body diagrams. Calculate the acceleration of the system. T2 is unknown and the acceleration is unknown. So I would need two equations. So for our first equation, I'm using A, and we start with F net equals MA. So MA would be, we need to choose our positive direction. I'm going to choose up as my positive direction, then down would be my negative direction. So up is a positive direction, down is the negative direction. There we have our direction sorted out. So T1, which is also your applied force, minus T2 minus MAG. The mass of A is 4. For A equals 120 minus T2 minus 4 times 9.8. So we get our first equation, 4A equals now 120 minus 39.6 is 39 minus, what is that, 4 times 9.8, that gives us 80. My 0.8 minus T2 forms our first equation. The second equation, we need to bolt from B, so MA equals T2 minus MG, and this M would be B. So this is my 6 kg. 6 times A equals T2 minus 6 times 9.8. 6A minus equals T2 minus 58.8. And that forms our second equation. I can see that in my first equation, T2 is negative, and in the second equation, T2 is positive. So if I add the two equations, then I would cancel T2. So that brings us to 10A, 4A and 6A is 10A, equals 80.8. The T2 cancels, minus 58.8. That would give us A, it's 80.8 minus the 58.8 gives me 22. Divide that by 10, and we get an acceleration of 2.2 meters per second squared, and that would be upwards. So we've done number A, we've done number B, and next we do number C. Calculate the tension in the string between the two mass pieces. That is T2. And I am going to use equation 2 for this. So 6 times 2.2 equals T2 minus 58.8. T2 would be equal to 2.2 times 6 plus 58.8 gives me a tension of 72 newtons. Right, that's the third problem. Next is the fourth problem. Come. Oh, this is the favorite type of question. A block M with a mass 2.5 kilograms is initially at rest on a smooth horizontal surface, no friction. Another block, little m, with a mass of 800 grams, this needs to be changed into kilograms, is tied to M with a lightweight rope that passes over a frictionless pulley. Calculate the acceleration of the system of blocks. In order for us to calculate the acceleration of the system of blocks, we need to do something. We need to draw a free body diagram for each object. So here we go for M. Now, I could include the gravitational force here. Most probably I should, but there is no need. Those two forces will be in equilibrium. They will not affect the motion. And the other force, the horizontal force acting on this M, is T. On little m, we have a gravitational force that will have an effect on its motion, and T will be going upwards in the string. So we have two unknowns. The acceleration is unknown and the tension is unknown. If that is the case, then I need two equations, and I am going to do them here. So for M, my first equation is F net equals MA. That's what I start off with. Then I say MA equals T. T is the only force acting along the horizontal. There is no friction in this case. So 2.5 A equals T is my first equation. For little m, the MA equals mg for the gravitational force minus T, because these two forces act in opposite direction, and I choose down to be my positive direction, then up would be my negative direction. So this is 0.8 A equals 0.8 times 9.8 minus the T. And this is my second equation. I take note that T is positive here in first equation and T is negative there in the second equation. So if I add equation 1 and equation 2, I should get the t's cancelling each other. So 2.5 plus 0.8a, that is 3.3a, equals 0.8 times 9.8 is 7.84. And now I can get the value of a, divide that by 3.3, and we get 2.38, if I round it off correctly to the second decimal, meters per second squared. And it would be to the right. Or you could say clockwise, because little m would go down while big M goes to the right. The second question is calculate the tension in the rope that is attached to the blocks. I'm going to use my first equation, that is the 2.5 times the A, which is 2.38, and that would give me the tension. Tension is 2.38 times 2.5. That is 5.95 newtons. Right, we've got one example to go to finish this video. Here we have 3 trolleys and a mass piece hanging down there. So the 3 trolleys, they give the masses 10 kilograms for A, 20 for B, and 4 for C. They are attached to a 6 kilogram mass piece D. The trolleys are consider the surface of the table and the wheels of the trolley and the pulley. Everything is frictionless. Everything there is frictionless. They want us to calculate the tension between A and B is called T1, between B and C is called T2, and between C and D is called T3. And without asking us, they want us to get the tension T2 and the tension T1, and then they ask us a funny question. How will T1 change if A's wheels and the table are no longer frictionless? We'll concentrate on that question a bit later. To solve the question, we need 4 free body diagrams, one for each object. So A's free body diagram will have a T1 in it. B's free body diagram will have a T2 and a T1 in it. C's free body diagram will have a T3 and a T2 in it. And D's free body diagram will have a T3 and an FG in it. I'm going to ignore the vertical forces on A, B, and C, because the gravitational force and the normal for each of those would be in equilibrium. They're not going to be involved in building our equations. So for A, the F net, which is equal to MA, would be equal to T1. So it is the 10 kg object times the acceleration would be equal to T1. This is my first equation. The second equation for B would be MA. So it would be MA equals, I'm choosing to the right as my positive direction, minus T1. So it's T2 minus T1. And if I can substitute the value here, it's 20A equals T2 minus T1. For C, the MA would be equal to T3 minus T2. So our M here is 4A equals T3 minus T2. Sorry, I forgot to number this equation as 2 and the next equation as 3. And we have the equation for D. It's MA equals FG minus T3. And if I substitute the values here, it is 6A equals, now the FG here would be 6 times 9.8, which is 58.8. 58.8 minus T3. This is our fourth equation. It seems like if I add all these equations, I am going to cancel all the T's. So then I would be able to calculate A. Let's do it in another color. If I add 1 and 2, I'm going to cancel the T1s. If I add the third equation there, I would be able to cancel the T2s. And if I add the fourth equation, I would be able to cancel the T3s. So in adding all these equations, it's 10A plus 20A, that makes us 30A, and another 4A, that makes us 34A, and another 6A, so 40A would be equal to 58.8. A is equal to 58.8 divided by 40, and that gives us a 1.47 meters per second squared to the right. Right, we've done the tension T. Oh my, I've done my own thing. No, we need the tension. We need the acceleration to be able to calculate the tension. Okay, so we haven't yet completed question A. So they want us to calculate T2. To calculate T2, I need to add equation 1 and 2. Let me remove all these lines here. Okay. So in order to calculate T2, I need to add equation 1 to equation 2. Then the T1s will cancel. Because in equation 1, T1 is positive, and in equation 2, T1 is negative. So we go for that option. 10a plus 20a would give me 30a, and 30 in this case is, sorry for that, and a we calculated to be 1.47 equals T2. So T2's value is times 44.1 newtons. Good, we've done that one. Next is T1. If I've got the acceleration, then I can use equation 1, and 10 times 1.47 would be equal to T1. So T1 would be equal to 14.7 newtons. And then that was number B. Now, number C, they want us to explain, to say how will tension 1 change if A's wheels and the table are no longer frictionless. Now, if that happens, the acceleration would be less, because this goes in, the friction would be in the opposite direction. So the acceleration will decrease. If the acceleration decreases, oh wait. How will T1 change if A's wheels and the table are no longer? No, then there would be a friction. Yeah, there would be friction. And the acceleration will be less. But the tension T1 will increase. Tension increases if the friction is increased. So with number C, friction will increase the tension. It would be more difficult to move A. Right, that brings us to the end of this video. You may watch it again or pause it whenever you need to. There is some homework or work done from your textbook that I have given, so you have time to do that now. Thank you. Hope to see you next week.